Good morning, everyone, and welcome back to another lecture of React.js. So in the last class, we had finished off our discussions about the Airbnb clone app and also the portfolio app, a little bit high-level overview to kind of understand not just the basics, fundamentals of the React.js environment and how it is used to create front-end UIs, but also to understand a very fundamental concept that is present in React.js, which is known as the concept of React props. Okay, in short, it is known as React props, but essentially what it stands for is basically the properties of the functional components that we use to generate our UI components that we have on the interface. So the overall idea behind React props was that whenever we are designing our application, as we can see here on the code canvas, that if we have a functional component, which is the app's main logic, and then we have designed separate or individual custom components for ourselves, which is going to kind of represent the different subsections that is going to be present within your user interface. And if you want to pass in different values to those components, then essentially whenever you are calling those components from, let's say, your app's main logic or from your index.js file, which is the landing page of your front-end component, then essentially during that calling or during that invocation, you can pass in different values to the functional components, right? And then in the definition or the declaration of the functional components itself, you can design the declaration of those functional components in such a way that the values which has been provided during the function call can be received within an object that we call as props, right? So whatever variables or whatever arguments that you provide here, whatever name it has, those names will be kind of abstracted as a key value pair within the object that is known as props, right? And then within the body of that particular functional component, you can kind of use object destructuring, or you can extract those individual values by using the dot operator and the name of the key that you have provided when you were making the function call and the name that you provided there, right? So this allows for you to kind of pass in values to your functional components and makes the React code reusable in nature and also composable because you're designing it as a function or as a module, right? So this gives you a lot of like flexibility with respect to designing multiple functional components without having to write them again and again, right? We also learned about the fact that we can use higher order array methods such as map, okay? And filter can also be done depending on the logic that if you're trying to reduce the size of your original array or something along those lines. Map is generally used to create a whole new array based on the logic that you provide in the callback function of the parameter of the map function, right? So that gives us ability to kind of go over a very big array of objects and stuff like that, and then kind of create a very custom code that needs to be populated based on the different index values of the data array that you are traversing over, right? So here in this example that we are looking into, we had created these cards component, which for every index of the array will have a different value of, let's say, things like the cover image, the rating of the listing, review, city, title, and all those things, right? So we know for a fact that we can store all of these information as individual indexes in an array. So if we need to map over those arrays, and then we need to create a function call for each of those different indexes, those unique indexes and the value that they contain, and then create a call to the card component in our React.jsx environment, then we can essentially use the map method to create an iterator that will go over each and every index of the array in every iteration. And then we can create a custom body, which will essentially reflect the function call using JSX syntax. And then we can use the iterator and then the object key to kind of provide the arguments to the function call, and then create an array altogether or create a return object altogether, which will then be passed whenever the UI needs to be rendered or whatever UI needs to be rendered. You can essentially call that object that you have created. And that allows you to kind of map your data into a new kind of data structure, and then use that data structure in order to kind of develop your whole UI component without having to write the code manually in a sequential fashion as you would have done when it comes to developing your UIs using, let's say, plain HTML and vanilla JavaScript and something along those lines. Okay, so continuing our discussions from this point onwards, there are a few more fundamental concepts that we have to cover in order to finish understanding the basic environment of React.js, right? So we started off with the React.js hello world code. From there, we kind of understood what is the project directory, what are the different files involved, what are the subdirectories involved, and where you put different components, what are the landing pages and those kind of things, right? From therein, we moved into understanding the concept of React custom components, essentially how designing is done using React.js to begin with, right? The fact that every different portion within your UI is developed as a function call, right? So you define it as a function, and then you call that function wherever you want to kind of consolidate the entire app logic together, okay? And then we understood the concept of React.js, which is kind of directly tied up to the fact that we are using custom components, which are nothing but functional functions, so to speak, but within the React environment. So when we develop React.js props, this allows us to pass in arguments to these custom components. And then depending on the body of those custom components, we can essentially consume those parameters that has been received by the functional components in order to render out a particular construct, but with unique values every time, right? Based on every iteration. So it is kind of like a repetition using functional components and iterators, so to speak, right? So the last few set of fundamental concepts that we have to kind of cover is to, at this point of time, make any kind of React UI dynamic and interactive in nature. So till this point, if you're just familiar with these three concepts, right, these three fundamental concepts, what you can create is basically a static UI at this point, right? So static UI using React. But that is not the complete extent of a fully functional user interface that you would want to develop. You would want to develop something that allows you or your interface to interact with the user itself, right? So that means similar to the examples that we did in, let's say, the calculator app for our vanilla JavaScript, or the quiz app within vanilla JavaScript, where the user has some ability to interact with your interface itself, right? So that is known as dynamic interface. That is known as the interactive nature of our web apps, right? And then to make it dynamic is directly tied to the interactive nature. That is, if an event takes place on your user interface through the interaction with the users, then what action are you going to take? So if your user interface can have some sort of, I wouldn't say conditional rendering per se, but the behavior or the nature of your user interface changes based on the interaction that the user provides. So that means if they click a button on your user face, or if they type something on your user interface, or if they checkmark any kind of radio button or checkboxes on your user interface, then based on those type of interaction, those triggers, essentially you will take some actions on the fly or dynamically, and then populate the results or render the results out on the browser, right? So in order to do this, there are a few things that we need to learn, right? The first thing is to basically have an understanding of how to implement event listeners using React.js. Okay. The way event listeners are done, if you remember, when we did it in JavaScript, in vanilla JavaScript, we were basically using the DOM API to store the different HTML elements that we have on our interface, right, or on our front end, using the document.query selector. And then we were passing in probably the ID or the class name or something along those lines, similar to a CSS selector. And then essentially that HTML element then can be stored as a JavaScript object, right? And then once that object was stored in our JavaScript file, if you remember, then we were using that particular object and then calling this method that is associated with the DOM API that was known as add event listener. Okay. And that event listener used to take two parameters. The first parameter was a string parameter, which identified what type of event are we tracking for that HTML element on which we are adding the event listener. And then the second parameter was essentially a callback function, which kind of wrapped the logic of what needs to be done when that event is triggered on the web interface, right? Which was basically the dynamic nature. So this together, these two statements together kind of wrapped around the dynamic and interactive nature of our web apps using vanilla JavaScript, right? So interaction was basically adding the event listener, and then the callback function, which will be there with its logic, the body of its logic will kind of dictate the dynamic aspect of what needs to be done when that interaction takes place, okay? The difference of this method to the React.js environment is that we don't essentially use the DOM API. There is a much more simpler way to kind of work with this, right? Know the fact that if we want to add an event listener to a particular HTML element itself in HTML, there is an alternative method, which is basically through the help of an HTML attribute that is known as onClick. Okay, and this is basically how it is written, that if a click happens, then essentially what are you going to do, right? On click, on type, on pre-press, there are many different flavors of this type of attribute. And then you can add interactive aspects to it using HTML attributes, right? We don't use this because that is basically a scripting process. So generally, if you're just developing using HTML and vanilla JavaScript, we would like to keep a clean separation between anything that is scripting versus anything that is HTML. Just like the same argument that we had, like we want to keep styling separated from HTML file and be consolidated in a CSS file itself, right? So we didn't use this, but this is an alternative way. If you do not want to use JavaScript, if there is a very small aspect of interactivity that you want to input or embed in your interface, then you can simply use an HTML attribute, right? So since we know for a fact that when we are working with React.js, right, the syntax that we use is basically JSX, right? And what we say is that JSX is HTML-like code. It is not HTML per se, but you see code which looks like HTML, but is actually JavaScript XML, right? So what we are going to be doing, or what we are going to be learning, is in order to implement event listeners through React.js, we are going to be using an HTML-like code for the implementation of this HTML attribute for onClick, right? But things are different here. Since it is the JSX environment, the onClick attribute will be essentially written in camel casing, and it will be basically a function within which we can specify the event and then the logic that needs to be executed when that event is being generated, right? So that is basically the summary of event listeners, and we are going to go over different forms of event listener that is there. Basically HTML elements that is a part of HTML forms, but how to implement those, same thing again, but this time in React.js. So the next concept that is necessary with respect to React.js and then working with HTML forms and then user values that is coming to us is basically the idea of React state management. And this is one of the most fundamental concepts that you can find within React.js as a beginner when you're working with it. And this directly relates to the values declared within the functional components, which might change over the course of the interaction with the user, right? So what do I mean by this? Well, think about it this way, that here in this particular example, in the previous example, this card was a component, right? And we had passed in certain set of props to this card component, right? So essentially, if you relate this to traditional programming, this is just saying that we are passing in arguments to this particular function, right? And we had designed this particular card component, or essentially in a manner of speaking, we can say that when we declared this card component, we declared the parameters such that these parameters can receive the arguments that is being passed to it. So let us just delete all of this unnecessary stuff. Okay. So it was designed in such a way that all the arguments that are passed to it can be received by this parameter, which is an object. And then we can essentially, extract these different key value pairs from our object using the object notation, right? So what we are getting towards is that the values that is present within the parameters, okay, is being sent from an external entity, right? So from an external source, which is somewhere probably an array of objects, as we have in this particular case, we are getting those values, and then we are passing that as an argument, which is being received by the parameter of our component. And that parameter essentially is called props, right? The overall process. So these are values. That is the values that we sent using props, the concept of props. We call that as external to the functional component. And the reason why it is external, because the functional components are not the ownership entities of the values that it receives from the outside. Okay, so there is another aspect or another side to these different variables or these different parameters that you might receive in a functional component, not receive, but might be present in a functional component. Take this particular variable, for example. This variable has been declared within the functional component. So now if you ask yourself that what is the ownership entity or who owns this functional component, or let's simplify this and ask ourselves that what is the scope of this particular variable, then it is quite evident that since it has been declared within this particular function, that means this function essentially controls the ownership entity of this variable. So in a manner of speaking, we can say that this value is internal to this particular functional component itself, right? So that means the value is being controlled by this particular functional component. So how do you keep a track of the changes in values for the variables which are owned by the functional component itself? That is, it is not external to the functional component, it is internal to the functional component itself, right? So that is the concept of state management. So what state management essentially tells us is the fact that if you have a value, so we can say that if there is a value which is internal to a functional component, okay, and essentially what we mean by this internal aspect is that the value, which could be in a variable, which could be in an object, which could be an array, it could be any structure, right? But it has been declared inside the functional component itself. So that means the ownership entity or the scope of the variable is that particular functional component. So if there is a value which is internal to the functional component, then how do you keep a track of the changes to its value over time? Over time, meaning that the life cycle of the program, that as long as the program is executing in our web interface and stuff like that, right? And this is pretty important. And this is the concept of state management in React. Because if you have to keep in mind that, let's say you had a simple counter, right? And every time the value of the counter changes, you re-render that new value on your web browser, right? So you can think of this way that, let's say if you have a very simple program, let's get some space here. Let's say if you have a very simple program and a web interface where you have some sort of a bubble or a div which shows you the state of the counter, and then you have two buttons, a plus button and a minus button. So every time the user clicks a plus button, you have to increment the value of this counter by 1. Every time a user clicks the minus button, then you have to decrement the value of this counter by 1. Right? So I can implement the entirety of this whole logic using React.js functional components. That is, I can create a component called, let's say, counter.js, and I can call this counter.js within app.js itself, or I can make this counter.js, since if there is only one custom component, I can make app.js to be counter.js as well, right? So now, in any case, if you declare this function, right, And then within this function body, you would have to create some sort of a variable, since that is a part of the component itself. We can say int counter, and we can set it to initial value to 0 in order for that to be rendered outside, right? And then we have to insert certain buttons with the help of event listeners, right? Because if a click takes place on the plus button, then we know what the logic is, which is to increment this value by 1. And if a click takes place on the negative button, it's basically a button which will show the negative sign. There's nothing called a negative button. So then that will decrement the value of this counter by 1, right? But essentially what you need to pay attention to from a conceptual standpoint is that this variable's value is changing, right? And it needs to be rendered. So that means wherever we have this return statement for our entire component, right? Which will essentially have the JSX code that needs to be rendered on the browser that will show the actual value. We cannot just make a call to counter, right? So that means even here, we cannot write something like div and then maybe wrap it around curly braces to identify or signify the fact that this code here is just JavaScript. We cannot just simply write this, right? We could have done that in JavaScript itself, but here this is not acceptable. Within the React environment, you cannot simply call the value of the variable and expect the final value to be reflected here. React won't be able to render that out. That is how React is set up. React doesn't operate along those lines, right? So we have to use what is known as state management, essentially, in order to kind of solve or code situations like this, right? We have to design these situations using React state management. And the way it is done, since the change of React 16.8 version, before this, React was used to be written as a class. Okay, so that means all of these different functional components that we see, people didn't use functional components because of situations like these state management and stuff like that. They used to define the functional components as a class before 16.8. But now after 16.8, the developers added these different factors that is known as React hooks, okay, which is basically they abstracted the class of the different functionalities that needs to be used, such as React state management, and they created these functions, right, which can be called for those hooks. So one of those hooks that is used in state management, so that we don't have to write everything as a class definition, we can continue to use our functional components, is known as useState. So somewhere the prototype of this useState function is defined. And then essentially what we are using is we're using it as a hook. So the whole concept of the hook is to kind of hook into something and then bring it into your picture, right? So if you go into fishing or something like this, think about this. You have a hook, you put it in the water, and when the fish takes the bait, you just pull the fish out of the water into, well, your open arms, right? So to speak, right? So you're taking some property which exists somewhere else, and through a medium, which is a hook, you're basically hooking into that particular property or particular function, and then using that wherever you want to use it, right? So that is basically the analogy behind hooks. So there are many different hooks in the React environment. So if we want to perform state management, rather than us having to write the complete definition of how state management needs to be executed, what we do is we use a hook that has been defined on top of a prototype, right? And we call that function. The hook is basically a function within our program, right? So that we can essentially make use of the functionality there. And then we can continue focusing on the actual logic of our function as to what we want to do by using that particular hook. So this hooks are basically function calls, okay? So the hook that is used essentially for state management is known as useState. And there are, of course, various aspects to the hook itself. So don't worry about that. We will talk about it when we get to that point. So, but this is the whole idea of React state management, that this needs to be performed anytime that we are trying to keep a track of the values that are declared internally to a functional component, right? The concept essentially changes a little bit to give you a brief overview of or like a idea far sight into what this can become is that if you want to control the values which are internal to the function, then that is good, right? That means that the value has been declared within the function itself, and the changes in the value takes place within the function itself, right? So I hope everybody understands what I just said. I will repeat that one more time, that if we are trying to track the value of a variable that has been declared within a function and the change to those values takes place within the same function, then essentially we can use what is useState, the ReactHook useState or local React state management, right? But what if this value, think of a scenario where this value is internal to this cards component, but this needs to be passed as a prop to another functional component where its value will change, right? So again, to repeat this, what we are saying is that if you take, let's say, this simple example that you have this counter component, you declare a counter variable, and the value of the counter changes within this component itself. So you can use local state management. But what if instead of the value of this variable, which is internal to this component, instead of changing it within this function body itself, it is passed as a prop to another functional component, and in that body, the value changes and it needs to be returned back and keep a track here. So that means you are declaring the function, you have the variable somewhere else, and then you're changing the value somewhere else, and you need to keep a track of where that change is taking place. So in that scenario, you cannot locally manage the state of a variable. Essentially, when we are saying state of a variable, it is what values it is undertaking, right? What values are being provided to that variable. You have to keep a track of it over time, right? So in such a situation, state management can be then distinguished into two different categories. So you can either have local state management, okay, which is to basically, keep a track of the state in a situation where the function is local to a component, the variable is local to a component, and the change in value of those variables takes place in the same component which it belongs to, right? But then if you have to have a scenario where the value of the variable changes in a completely different functional component, and then you have to keep a track of it, that is, whoever is the owner needs to keep a track of the value, essentially, if you're using local state management. But it becomes very difficult or very tedious. It's not that you cannot use local state management to basically keep a track of the values in such a situation. So what I'm essentially referring to is that, let's say you have a root component here. That is known as the app component, right? And the app component, let's say it calls 3 more components, and we can say we have a hero component, okay? We have a card component, and then we can say we have some sort of results component, okay? Within this results component, we can have things like user results component, user component, and then we can have product component. Here in the hero, we can have sale component. And let's say in the user component, we have something along the lines of, let's take some example, and we can say undergrad component, although this is not the best example, but I'm just creating some components here, right? Grad component. Now, let's say we have this grad component here, okay? And then it has some sort of value, let's say research credits. That is basically a part of this component itself, right? But this component needs to be passed, or this app component essentially changes the value of this R credits, right? So then this grad component needs to keep a track of what is happening within the body of the main app component to its value research credits. So this is a very problematic scenario, because now we have to undo the changes here, right? And we have to take it back up to this point. Or you can think of it this way. Let's say the app component has some sort of a variable that it owns, right? Let's say it is some XYZ variable. And then it uses props to pass those values to the next child component. It takes it to the next child component, and then it takes it to the next child component, right? And then within that child component, the value changes. So then how does app component keep a track of the changes that is taking place way down the DROM structure, right? Way down the tree of the DOM structure. So in such a situation, if you're using local state management, it becomes really tedious to keep a track of this, right? Because you have to propagate the changes back to the parent such that it can use the local state management, which is present within its function body, in order to update the scenario such that the updated values can be rendered on the page, okay? Because if you do not keep a track of this, the changes that are taking place to your local variables, they will not be reflected in the browser, right? If you do not have state management, you cannot simply call the variable's name like you would do in JavaScript or any other programming language and expect the final value to be shown to you. That's how React is essentially set up, right? So in a situation like this, where you have this multi-level tree arrangement, and then the value of a local variable, which belongs to a functional component, changes somewhere far away from its original source where it has been declared, using local state management is a little bit difficult. So what we do is we wrap this entire app around what we call as a data provider. Okay, we kind of wrap this entire app such that whenever it comes to working with any variables that belongs to a particular functional component, instead of doing that within the body of the functional component, instead of keeping a track of this, we create a data store or a data provider, and then we connect that to the entire app, right? Not just to one single functional component, but essentially to all of the different functional components that might exist in your app logic, right? And this data provider essentially provides global state management. So anytime this guy changes things and this guy needs to keep a track of what changes happen, it just queries that data provider, okay? And then it gets the updated value, and then it can render the updated value on our browser UI, right? So essentially that is the ease of use with respect to, rather than traversing this whole tree back and forth in order to keep track of the changes that is taking place, it is just a single bidirectional communication that can take place with the data provider, which wraps the entire app, right? So this particular scenario of state management using this wrapper of a data provider, that gives rise to the second aspect of state management, which is global state management. Okay. Now, as we discussed, local state management is implemented using a React hook that is known as useState, okay, which is essentially a function, all right? Global state management needs to be rendered or implemented using third-party providers or third-party packages. Okay. And the third-party packages that we will essentially learn a little bit later, after we have covered all these fundamentals, is known as Redux. Okay, so Redux is the third-party package that essentially helps us to implement the concept of global state management. And what is the concept of global state management? What we do, essentially, we take all the variables, which is internal to all the different functional components that could be present within your app logic, and then we put it inside what is known as a data provider, and we implement state management within the data provider. So anytime a value changes, that information will be sent to the data provider, and the data provider will update the state. And then anytime any other component wants to get the most updated value of a particular variable that it needs to use, then it will query the data provider, and the data provider will send back the results, right? So essentially, for simpler applications, and by simpler, I mean when you're not moving the values around too much, then you can simply get away with local state management or using the React hook useState, okay? But if you know that you have an app logic where variables that are declared for different functional components needs to be moved around, that is, these values needs to be queried by other functional components, then instead of using local state management in combination with React props, it is much easier to implement it using a third-party packages like Redux. Okay, some of you who might have worked with React before might have heard this term, or some of you who might have already used it kind of have an understanding, but those who are new, try to follow it with respect to the concepts that we're discussing here. That is, what is the whole idea of state management, how it is defined, and what are the two different types of state management that you can have, the scenarios that you can have, which will kind of dictate the use of either local state management or global state management. Okay, so these are the two fundamental concepts that will help you implement dynamic and interactive nature in your React applications. That is how to implement an event listeners and how to perform state management. Okay, and the third last aspect that we will cover through the current exercise that we will kind of undertake at this point of time is the idea of API calls. Okay, so what it means is that, let's say if you want some sort of data, let's kind of revisit this particular application. And how do we do this? Don't say, right? Let's take a full stack application, right? We will slowly kind of jump into the notion of full stack development. So when you're developing a full stack application, right, you have this front end side. Okay, so we will call this front end. And then we have this back end, which is basically your server, and it has certain set of logics. And then here, let's say we have a database server. Okay, so we will say database server, essentially. So the backend is basically a bunch of scripts, right? Or you can call it a backend being a bunch of functions, which is essentially implementing the functionality of your entire app logic, right? So if you have a search functionality, then there will be a function or a script which is with respect to how to perform that search. If you have a, let's say, create a new user, then you will have some functionality to create a user. If you want to see, let's say, your results of a search, then there might be a functionality of how to kind of create those results in a structured fashion and send it back to the client, right? So the UI part is on the front end. The logic of your application is hosted on your back end. And then essentially your data is stored inside your database server itself, right? So anytime there is a query that requires you to either read data, write data, update data, or delete data, then that request goes from the front end to the server side in the form of an HTTP request. Okay, once it is received by the server, the appropriate script will be identified based on the URL of the HTTP request. So if I have a request which sends it to the user creation, then we will essentially invoke the function. And let's say if there is a read, write, update, or delete operation on the data, then the server will essentially execute the request to the database server. The database server will respond back with the data. Then some sort of function, either the same function which invoked this particular request or some other function, depending on how you have designed this backend, will take that data, transform that into a presentable fashion, and then send back the response to the client or the front end in the form of a HTTP response. Okay. Now that we understand this, if we think in terms of developing the front end using React, let's say we have developed this using React. We have developed this using, let's say, Node.js, which is also JavaScript backend. So we can say Node.js with the help of Express.js, which is the server-side framework. So if React is the front-end framework, that is an extension of JavaScript itself, then Express.js is basically the backend or server-side framework, which is an extension of Node.js. And Node.js essentially is written using JavaScript inherently, right? Which is wrapped around with C++, right? And then let's say this one is basically using a MongoDB, which is the NoSQL database. So when you create a full stack like this, this is known as the MERN stack. Okay, some of you might have heard this before, or some of you might have also heard the LAMP stack if you're using Apache, PHP, or Linux in order to develop your applications, right? So this is known as the MERN stack if these are the technologies that are involved, right? So you have MongoDB, you have Express, you have React.js, and then you have Node.js, right? So this is basically the stack, the full stack that we are implementing, okay? But essentially what the idea is, when these request and response are sent out, right? What is the format of the data that is preferred in order to send the data back and forth? That is, when the database sends the data and it is received by the server here, how should the server package the data and send it to the client? Well, the preferred way of packaging the data, the format that is used is JSON, okay, or JavaScript object notation. So if you think of JSON, you would have an object-like notation where both the key as well as the value is treated as a string. Okay, unless there is a number or something like that, then you don't treat it as a string. So essentially what you can do is, if you have objects, right, then you can use what is known as in JavaScript the stringify method to transform a given object notation into a JSON notation, right? And then that JSON notation can be transported or essentially transmitted very easily to the front end. And the front end essentially can pick up the data, because we have seen how to do that, and then kind of render it out on the UI itself, right? So what we develop here are basically JSON-based APIs. These different scripts or functions are defined or as JSON-based APIs, such that they can return these JSON objects, okay? But now, if you imagine what we are working with is just focusing on this area here, right? So our concern is how to develop this. But that means we still have to understand how to handle this situation. That is when a response is coming either from a server or any kind of third-party APIs where data is present, okay? Or essentially, if you want to summarize this question, what we are asking ourselves is how to handle data which is in JSON format that can come from our backend, or that can come from any other third-party API calls, okay? So that is basically the concept of understanding how we should handle API calls on the front end. Because if you understand this API call, then all you need to know is what is the format of your data that is coming, or what are the key value pairs. If you know this, then that's all you need to understand and implement it. You don't care what backend is there. You don't care if it is your backend. You don't care if it is from a third-party backend. You don't worry about all of these things, as long as you know how to handle API calls with uses JSON data format, right? If you know this, then you can implement it, okay? So to do that, we will essentially do the last exercise, where for the project or the demo that we will be doing, essentially we will be implementing an API call, okay? And then we will be getting that data. So when we handle an API call on a React UI, there is another hook that we need to kind of learn, is basically what is the implications of technically what they call it as a side effect on our app, right? And the hook that is used to kind of manage that is the useEffect hook. This is again a function which has a prototype defined somewhere else. We are essentially just hooking into that particular functionality and bringing that in our particular application. Because what the whole idea of this is, whenever data is received, right, it might not be a single data value. It could be a stream of data value that keeps on coming, right? Or it might keep on refreshing itself after every 5 minutes, 10 minutes, 1 hour, whatever is the logic of this particular backend that has been implemented here, right? Whatever it is, it could be your own server, it could be somebody else's server, whatever that might be. We don't worry about that, right? But it could keep on sending this response with data, depending on what type of request you have made, right? So your front-end UI or your front-end framework or your front-end server could keep on receiving data value, right? Either periodically or continuously, depending on whatever the logic is. So those will have an effect on how the data needs to be rendered or how the data needs to be updated on the front-end side, right? So of course, state management will be involved, because you will be storing this data that will be received right here using some sort of variable that will be declared within some sort of functional component that will be responsible for handling this particular request, right? But there is also a factor of when this is done. That is when the stream ends. You have to keep a track of that, and you have to update your UI based on that. So that is the idea of this side effect. That the reason why it is called side effect is because we just learned that when it comes to state management, whether you're doing local or global, it doesn't matter. But these values, the ownership entity, are essentially the functional components, right? So that means the React UI or the React framework has control over these values. Okay. However, if you think of the values that is coming in such a situation, the UI has no control over these values, because if you think of this red line here as the boundary between what React can control and what it cannot control, then we can clearly see that these values that are coming from API calls are coming from outside the control of the React UI boundary, right? So React has no ownership entity over these values. So you cannot use pure state management, like state management in a standalone fashion, to keep a track of what is happening with these values. So I hope everybody understands what we're talking about here, right? Since React does not own the values that are coming from API calls, it belongs to some entity that is outside the React boundary, this particular boundary, then we need to provide React UI that we are developing with some form of control to manage these values alongside with state management, right? So to give React an idea of like, okay, we are done with sending the values at this point of time, or hey, there is a new set of values that came to us and please update this as well on your state and stuff like that. So that is basically the idea of side effect, because it is an effect that is coming from outside, right, of the React UI. So there needs to be some form of control. React cannot do it in an inherent way because it has no ability to do that. It does not own those values, right? So we need to provide React with some additional measures alongside state management, whatever that might be, local or global, doesn't matter. And that is done through this hook that is known as useEffect, which is basically able to understand when the values are coming, and how the values needs to be checked, whether it is being updated or not. So those kind of behaviors that needs to be implemented. So this is basically the three main concepts that we are going to learn through the demo that we are going to be doing to wrap up our React fundamentals, right? And the way we are going to be doing this is through this interesting demo, or this kind of quirky demo. You can do it in many different ways, but the way I will show you is through what is known as the meme generator app. Okay, so the whole idea of the meme generator app is pretty simple. All right, so well, I don't want to save it. So the whole idea of the meme generator app goes something like this. So as far as the design itself is concerned, we will have a single page app, which is mostly what we aim for when it comes to React.js itself. We will have a header component. Okay, we will have two components. One component is basically the header component, and then the other component is basically the main component. So you can either call the second component, which is going to be your main component, as meme.js, which will cover the rest of the page. And then we can have a separation. We don't need to, but let's say we can have a separation, and we can say that we will create another component that is known as header.js. Okay, so the header.js will basically have the title of the page, and then it will have some sort of a heading logo, some division and stuff like that. If you guys want to add some sort of a search bar, nav bar and stuff like that, you can go ahead and do it, try out implementing all those things. The meme.js component will have two input text fields, okay, within this component. And what this field will have is basically two set of text, right? The text that will be displayed on the top of a meme, and the text that will be implemented on the bottom of a meme, right? So what I mean by the top of a meme and bottom of a meme text, so let me just show it to you so that you can get a better understanding of what we are referring to. So now everything is a meme nowadays, right? Okay, so move this to a new window. So if you look here, right, if you look at these meme images, we want to generate this through our application, right? So that means every meme, if you notice here, there is a top image, top text, and then there is a bottom text, and then there is an image. So there are three content in order to generate this particular meme image. That is a top text and a bottom text and a meme image itself, right? So that is the idea, or that is what I mean when I say top text and when I say bottom text, and the next content that is coming is basically the image itself. Now, in order to create an image, we will essentially have, let us call it a button. Okay, so we will have some sort of a button which will generate or pick an image in random, okay, from a repository that we will have. All right. And then finally, we will have some sort of a display section here, which will also be a part of the meme.js component. And the reason why we are not separating the component here that you see here from the meme.js component, we're not making a separate component call to this, is because then otherwise the local state management concept is going to start becoming a little bit complicated if that ends up happening. So what we want to do in this display component or the subcomponent within meme.js is that we will show the image which will be populated when this button is clicked. And then on this image, we will have this user input top text, which is basically a dynamic content. This image generation is also dynamic content because when the user clicks the button, it will populate a random image from a repository. And then we will have a bottom text here, which will be picked up from this particular text field. Okay, so the user can provide inputs, the user can provide clicks. So that means it takes care of two different event listeners. And then we will display it here. So the value of these variables are changing because the user can give the value from time to time. So that means we need to have state management to keep a track of the changes that is taking place in these particular fields, which will be stored as a variable at the end of the day within the component meme.js. And finally, the way we are going to, at the very end, right, not at the beginning, this repository that will give us the image will be in the form of a data.js file. So we will keep it locally initially. So this is the first step, but later on when we're done with this entire design and implementation, we are going to remove this local storage like we did previously as well. We are going to remove this local storage and we are going to replace this essentially with an API call for our meme generator, okay? So we are going to make an API call to a third-party application which actually stores the images, random images of random meme images. And we are going to make that API call, and then we are going to dynamically make an API call every time the user clicks a button in order to grab an image from a third-party API. Now you can think of that third-party API as your own backend and stuff like that, but this will give you an idea to kind of how to complete that gap of, okay, I developed a front end, now how do I connect this with a backend? Well, this is how you're going to be connecting it with the backend, right? So this is basically the overall logic of our app design, right? Pretty simple, single page app, which allows dynamic and interactive nature to the users, essentially with API calls, right? So that kind of completes all the basic stuff you need to perform in order to develop a React applications, which is dynamic and interactive in nature. Okay, so I hope everybody understands this. If you have any questions, you can let me know, and then we will move forward with respect to working with our actual implementation step by step, and take care of all the things that we just discussed here, right? Along with the functional and conceptual aspects, right? So any questions till this point?
Not at the moment.
Okay. All right. So I'm going to clean out the canvas here. And as you might note, I don't need this. I have created a new fresh application or working directory here, which is called ReactState_23. And by the way, the entirety of this code is also available on GitHub on my repository. And the repository's name is meme generator, okay, which is written in camel casing. So you can essentially grab that entire code from there if you would like to refer to it at any point of time, or work with me when I'm doing stuff as well. So everything has been generated, and we have these basic boilerplate files that we had initially generated whenever we run the code of create React app. So I use npx create React app, and then give some random name of like my app, or you can give a better name than this, when you're working with it, or you can create it in the root directory. So that will require you to first create it and then import it into your Visual Studio Code workspace, right? So first and foremost, we have to go ahead and kind of remove all of these different files. So what I'm going to do is, instead of doing it one by one here, I'm just going to go find where this file is in my actual local computer. And then I'm just going to remove all of these unnecessary files in one go from this particular stuff. So I need to find out where ReactState23 is. That sounds like a band name, but okay. All right, so we need the index.html file that we have here. But other than that, I think none of the other files are required here. So I'm just going to take everything and then delete it. Okay. And then coming to our source folder, which is this particular folder, let's see, we don't need app.test.js. So I'm just going to remove that. We don't need the logo.svg. So I'm going to remove that. We don't need reportvitals.js. We're going to remove that. We don't need the setup text either. And we are going to remove that as well. Okay. So we have app.css, app.js, which is the app logic. Let's keep that. We have index.css and index.js. Now, you don't need to have both the CSS files unless you want to. That is completely up to you as a developer, how you want to set this up in terms of CSS. Some people I have seen just use a single index.css and they just treat that as the sole area where all the CSS is. Some people who, for very big projects, what they do is they write their CSS file for each component that they have, so that, they can focus on the individual portions. Since you're dividing it up, might as well do it, right? So let us see if there is anything else here that we need to take care of. No. Okay. So that takes care of it. And for now, what we are going to do is we are going to go into index.html and kind of remove anything that we might not need here. Okay. So we don't need this because this is going to break. We remove the fav icon. So viewport can stay, theme color can stay, description, you can remove, you can kind of update this. The April touch icon, we don't have any April touch icon remaining. We don't have any manifest file either. And then we can remove this and we can say, instead of React app, we can say React meme generator, or we can say React state demo, React state mgmnd demo, something like this. Kind of focus on the actual concepts itself. We can keep the NoScript file and we can keep the root element. All is good. So this is the first step that we will do, kind of take care of all our HTML, which is the main landing page after all. And then once the HTML is taken care of, we will go to the main landing page on the React side of it. This is good. Index CSS is good. Bringing in app is good. We don't need this report vitals. So we are going to remove this. And then we are going to remove the report vitals from here and remove all of these comments. This is not necessary. And then we can keep the React strict mode. That's fine. It uses all the React DOM stuff. If you don't want to use it, it will render just fine. So you can keep it, you can remove it. It's kind of up to you. I will keep it for myself. Okay. And then it creates our root element for the React DOM and it connects that to our HTML file and it calls the main app or wherever the main app logic is. So once we are taking care of this, we will move on to app.js. App.js imports a logo. We don't need any logos, or we don't have any logos. We have deleted all of them, so that will give us an error. It imports the CSS file. Let us keep that there. Then there is a div, which has a return and a header. So we don't need any of this. What we are going to do is essentially remove this whole content. We will say div. Okay. Let's say give it a class name, and we can say app wrapper or app container. Okay. And then inside of this, let us give an h1 tag to do a sanity check. And then we can say app heading and it works. Something like this, so that we know what is happening. And then what we are going to do is go to the index.css file, comment all of this for now, because we are not going to be using it. Maybe if we use it, we will uncomment and come back to this. And then in the app.css file, we are just going to go here and remove everything that we see here. So I'm just going to delete everything so that nothing is shown. So this essentially will revert back to the default CSS stylings of the browser itself. So that's okay for now. We are not much worried about it. I have already written my CSS and I will give it to you. You guys can use that same CSS as well. Pretty straightforward, right? So once every file is set up in the systematic order so that hopefully we have not missed anything. If we did, we can come back and check it again. Essentially, then we need to CD into the app, which has all of our files. So I'm just going to go ahead, CD into my application. And then once that is done, in order to start my front-end server, I'm just going to execute npm start. So let us go ahead and wait for this to create the server. Okay, loading, compiled successfully, and I can show you that it does work here. Okay, so this is what we had written. So everything is kind of working. So it passes our sanity check that our app is ready. And now we can start creating some of the, essentially some of the customized structure that we need in order to work with this particular application, right? So from this point onwards, for most of the apps, what I generally do is I keep this browser running and I go here and I open a split terminal with another git bash default, kind of make sure that it's in the right folder first and foremost. So I have to get out of here. And then I have to CD into ReactState W23 and then CD into my app. So I create these two ones so I don't have to mess with this or stop this anytime I want to install something. So I have these two things just working with me side by side. And that's kind of easier, especially when you move to React Native. You would need a lot of third-party packages, one after the other. So in such a situation, instead of working with a single terminal, it's kind of helpful to have this set up here. It's easier to kind of keep a track of what you're up to, right? So I don't need the index.html file at this point of time. Index.js file is not required either. We will not mess with CSS for the time being. So I'm just going to keep it here. So let us set up the remainder of the directory structure that we need. So in the src folder, okay, so let us just see what things we have here. Okay, so we will CD into the src folder. Src folder should consist of all the information that we have here. Okay, so we only have files at this point of time. So I'm going to create a directory and we will call it components, because that is what is going to store the different components that we talked about here. That is, we will have a header component, which will consist of this piece of information. And then we will have a meme component, which will basically be the main bulk of the app logic that we are going to implement here, right? So I'm just going to create a subdirectory for that. And then if you want to put some images and stuff like that in the source folder, then essentially we can also create mkdir images subdirectory that will store all the media files. So if you have more media files, you can put it in different folders like audio and video and stuff like that. But it's always good to kind of create these individual structure, so kind of so that you are aware of what you need to do, right? So the main components that we need, or the main files that we need inside our components, as we discussed, are two things: this guy here and this guy here, right? So two components that we need to create. So I'm just going to go ahead and CD into our components directory, and then I'm going to create two different files. The first one is going to be touch header.js, and remember, component names start with a capital letter. Okay, so touch header.js is the first component that I'm going to do. Touch is a Linux command, by the way. And then the second one that I want to create, or the second component that I want to create, is meme.js. Okay, so once I have created this kind of takes care of the structural aspect of how I want to develop this particular page. So I have the header.js and I have the meme.js ready, right? So what I need to do, once you have created any kind of component, you need to populate it with boiler template code, right? So if you go to the boiler template code, what we will do is we will open header.js, we will open meme.js, and then here, if our Redux, React Native, and React Code extension is installed for our Visual Studio Code library, all we need to do is write down React functional code, functional component with an export statement. So once you do that, this will essentially generate the boilerplate for us with the export statement that is necessary for us to kind of move everything outside of this particular functional component, right? So inside of this, what we will do is we will not use this default statement. We will put an H2 header, and then we will say this is the FC functional component for the page header. And then we will do the same thing. So React functional component, not for each, React functional component with an export statement. And here we will just delete this, come here, give an H2 again, and we will say functional component for user input and output display. Right? So we will just kind of write down what is the logic, and then we will implement that, right? So now I have two images that I would like to use as a logo within my header file, like we discussed here. So I have one image here, and then I have one image here. So you can choose any random image that you want to put there. You can choose not to give an image if you want to, but essentially what we are getting at is if you have something that you are working with, then you can essentially use that image in those particular directories. So I'm going to copy the images that I have, okay, and bring that into my images folder. So I'm just going to paste that there. So you can see here right now I have these two images. You can use whatever images that you want to use, right? So the images that I'm using essentially is this guy. So I just downloaded this guy from the internet, and then I'm just saving this there, right? So you may go ahead right now, if you're working along with me, you can download any quirky image that you want, or any image that will look something along these lines, and you can essentially use these images, right? If you want to use the same images, you can download it from my GitHub directory, and feel free to kind of work with it, right? But images are not that big of a deal with respect to the functionality itself. It's actually what we are trying to code that matters more, right? So essentially, what we want to do after this point of time is basically start working with the design of our app. So let's take care of the very simple thing first, which is basically this header component here. It's pretty straightforward. It has a title, it has some sort of image, and that's about it. That's about all that we have here. So this is something that is coming from the static side of our development, right? We are not doing anything new here. So I'm just going to quickly go ahead and address that in the header.js application and take care of that first, right? So this is going to be quite straightforward. So in the header, the first thing we need is the logo that we want to essentially use, right? So what the logo that I'm going to use is this Pepe face header .png file, okay? So I need to import that into this particular file. It's a plain file itself. So what I'm just going to do is import, and I will say logo, and then I will say from, and then I have to find where this image file is. So right now I'm inside the components subdirectory. So I need to move one level up, go inside the subfolder images, and then within that, I have this image file that is known as Pepe -face -header .png. Okay, I've kept one which is JPG, I've kept one which is PNG. So whichever one you have to use it, you can use it. So now I have brought in, or I have essentially imported the file here. And now we need to essentially finish off this particular class or this particular component, which will have essentially the logo, then the title, and then some sort of text, if you will, to describe what is happening, right? So what we are going to do is, instead of using a div, okay, we are essentially going to use a header tag, right? A semantic header tag, which will make a little bit more sense. So alt click this, left click, okay? So press alt and click the areas where you want to make the changes. So I'm going to hit backspace 3 times, And then I'm just going to do a header tag, right? And then essentially just click somewhere else and this takes it. So this allows you multi-line editing if you're doing the same edit anywhere. So you just press the Alt, left click in those multiple locations, and then you can make the edit, right? I need to give it a class name in order to identify it in my CSS file. And this is up to you. This is subjective in nature. There is nothing too complicated that is happening. Whatever name you use, essentially, you just have to remember that to use that same name when you're working with it. Okay. So now here, I'm going to retain my H2 header, okay, which is going to remain as my title. And then I also want to give some sort of an H3 following the hierarchy. And this will be for my text to describe what the site is about. So the last thing that we need essentially is the image itself. So I need an image tag here. Okay, this is behaving. Why is it behaving like this? Give me 1 second. This is behaving in a way that is kind of giving me the jitters. Okay, yeah, the indentation is off. Okay, so we need the image file here. And the image file is always a self-closing tag. We know that. The image requires a source. And we know that the source is basically present inside this object. So we are just going to do equals and then curly braces because we want a JavaScript code right now. And then we put an object assignment in order to assign that value to the source file. In addition to the source file, we need a class name in order to identify what are we essentially doing or what are we working with. So we can just give header dash image. Okay. And then we need some sort of an alt text, at least the field to be present. You can leave it empty if you want to, but here I will say logo image for web application or for meme gen application. Okay, meme generator app. All right. Next comes the title of the site itself. So I'm just going to put it within H2. And what I'm going to do is, first of all, give it an identifier in the form of a class name. And I will call it a header title. Okay. And this header title will have some sort of message. Instead of saying that this is the page header, we can say that it will have something like this, like welcome to the meme generator app. Okay, so we do something like this, which will be much more understandable as to what we're doing. Then we will have probably an H3 tag following the hierarchy. We will give it again an identifier, just like we did. So we can say this is going to be my header text. All right. And then the text that we essentially have is a description of what this website is. And we can say dynamic and interactive web app to generate your own memes. Whatever information that you want to give, you can give it there, right? You can give the version, you can give whatever information that you would like. And that's about it, right? And I believe what we need to do is essentially incorporate this within our app.js, right? So we essentially need to make a function call. Here we just define the body of the function. Now, what we need to do is essentially we have already exported this. We need to import this function within the main logic, which is app.js. And then we need to make a function call here, right? So what I'm going to do, first of all, is here we are going to say import different functional components. And you can say functional custom components, or you can just simply say custom components, because when you say custom components, that is something it is you have written those components, so to speak, unlike this app and index.js, which is already there, right? So we need to bring in our component. So we are going to import header from, and where is it right now? So we are in the root directory, and this component is essentially inside this /header. Okay. So notice here previously in the previous exercises that we did, I wrote the header name first and then I imported it. So it, or by default, VS Studio Code understood where it is coming from. But if I go the other way around, that is if I import it first, you have to write down the whole thing. It will know where it is coming from. Okay. So that is one thing that you have to remember. And instead of having this H1 tag here at this point of time, I'm just going to make a call to my header component, which is already here. Okay, as long as I have spelled it right, everything should be good, right? So we have one warning. Where is it? It's again with respect to that alt attribute, I believe. So in component header.js, we have line 77. So header.js line 77. This thing, something is wrong with this, and I don't know what exactly am I doing wrong. Okay, so let's save this again. It still complains about it. Okay, let's leave this here. I have to spend some time here. Redundant alt attribute. Screen readers already announced. Oh, I see. Okay, so what it is referring to the fact that screen readers will already announce this image attribute. So we don't have to write a separate attribute here in React where we have to provide the alt prop, right? So it's a little bit different from HTML apparently. So we are going to remove this and we still get it. Where is the image again? Image, but we have removed it. What have I not saved? Do you guys see anything where there is an alt text anywhere?
No.
So why is it complaining there? We'll come back to this. And let's just check if it actually generates that thing or not. Okay, so we'll go here. And this is what we have at this point of time. Okay, so we have the image as identified. Actually, I have to find a screen reader. And then we have the title here. We can probably change it to H1 if we want to, but we'll keep it small. And then we have this particular aspect here, right? So looks pretty good. Looks pretty straightforward. But essentially, we need to give it some sort of CSS. What I'm going to do right now is I'm just going to dump my entire CSS here in one go, rather than figuring out the CSS one by one. So we are going to go to app.css in order to minimize this situation here that we are dealing with. And then from the app.css, I'm just going to take my CSS file that I have generated. And it also has some CSS for the future elements that we are going to be working with. But essentially, the focus here is going to be this header class that we have here in in the header component. And then we will have, then I have one for the header image, which is the image itself, the header title, and then the header text. Okay, so till this point is basically what we have with respect to the CSS for the components that we have actually coded here. Okay, and inside of that, there is nothing new. Basically, I'm applying a flex in order to arrange all of these three different components that we have, or these three different elements that we have. So it will space it out nicely, applying some background color to it using linear gradient, some padding, some height, and then some height and margins for the remainder of the three things that we have inside the header itself, right? So we will save this. And essentially, if we take a look at it again, okay, so this is what we are getting, right? So you can kind of space this out a little bit more. This kind of is reduced, but it creates a nice little banner. Okay, you can kind of work with this and you can change these things and see if you would like to kind of make it your own. So you can move this here in the center, or you can move this around, or you can give it a new styling altogether to work with this, right? But that takes care of the first design aspect that we have, which is to just deal with the static part of our website, okay, or our web application. Now comes the important aspects, the new things that we need to learn is how to implement these, the event listeners, and then how to work with this button. API call will come at the very end. For now, what I'm going to do is I'm just going to use this local data storage, which essentially is getting the API call and saving it in a JS file. So I have done that step for you till we get to the point where we can actually do the API call. And then generating this image is not the problem. Nothing is a problem. The challenge is to make sure you use the correct CSS to display it in a way that is similar to cloning a proper meme image, right? That is, the text is in top and bottom on the front, and then the back is the image itself, right? So that is more of a CSS issue rather than a React.js issue. So we can kind of deal with that when we come to that point, right? So essentially what we want to talk about first and foremost is how to essentially perform different types of event handling, okay? And the moment we get into event handlers, we need to talk about state management, because if you cannot do state management with event handler, how are you going to keep a track of the data that will be provided by the users in these particular fields, right? So that raises that same question. So we're going to take a detour right now, and then we are going to move into a completely different territory, which is to understand how to work with HTML forms, but this time in the React environment. So remember, we talked about HTML forms, we did input fields, we did text area, we did check buttons, we did radio buttons when we were discussing just HTML, right? Submit buttons and all those things. So now, how do we do all of those things? But now in a situation where we are working with React.js itself, right? So that is going to be an integration of working with both your what do you call, not just your event handlers, but also React state management itself. So the first thing is we need to understand state management, okay? And what are the different components of state management? So we need to go back to our drawing board in order to establish how state management, I can just say state management is done in React, okay? Using the ReactHook useState. So essentially that's the hook. This is present in the React library itself. So if you do not import this particular thing in its own object, then essentially you have to call it like this, react.useState. So as long as you import React, then you can do react.useState in order to get it, right? In case you do not import this separately, right? So if you import it separately, that in the import statement, if you write a destructuring where you bring this call to its own object, then you can simply call this. So you will see some code that is just calling React useState. So notice the import statements in those codes. You will see that they have imported it in its own container. So that's why you can use it. We are going to keep on using it like this. The reason why is for beginners, we want to understand that this hook is a part of this library itself. It is coming from React. So this is going to be a reminder for us that this is how it is happening, okay? So when you're doing the React.js or the state management using useState, the first thing that you have to do, okay, the first step, so let us call it step one. The first thing that we have to do is we have to set out the initial state of the objects. We'll call it objects, will be variable, whatever, we'll just call it objects altogether, okay? So we need to set up the initial state of the object. So that will be some sort of a declaration with the React hook itself. So we need to kind of configure it up in order to set it up, okay? So when you set it up, essentially, you provide two different, or when you call this particular function, it returns you with two different values. The first value is the container, which will store the actual value. And the second is going to be a function call, which will allow you to update the value. Remember, this is coming from a class implementation. Okay, so in classes, let's take another detour. If you have a class, right, and let's say class student, I can create a bunch of data members here, right? So I can create something like public. I can give an iterator here, and I can say int student GPA, or just say GPA itself, right? Not public. Let us remove this public. Let us keep it default, which will make it private in Java. Okay. So if we do just this, and now if we want to create an object, we're simply just going to say student type, and then we will give it some name such as XYZ, right? So this will create an object of type student, right? Otherwise, you can create a constructor and you can assign the data member variables. However, if you want to take this XYZ and you want to update the value of student GPA, you cannot do XYZ dot GPA equals 2.5, whatever. You cannot do this. This is incorrect, right? Because this is private. Objects cannot access private data member variables directly. You might be able to do it in a public member variable, but you cannot do it in this situation where the data member variables is private. Okay, so that means inside the public, I need to create what is known as getters. If you all remember this from your object-oriented programming class, and setters. The getters will allow the objects to read the values that is associated in the private area of this particular function, this member function. And then setters will allow you to update the value of the private member variables that this object is trying to access. Okay, so that means if I want to read the value of my GPA, then I will have to declare some sort of a getter, which will say something like get. Getters always have the prefix get, setters always have the prefix set. So get something like student GPA. Okay, so this is going to be a function call essentially, and this will return me just the value. Similarly, if this object is trying to update this value here, then it would have to call the setter, which would look something like set student GPA, and it will pass some sort of a new value, let's say 4.0, right? Because setter takes argument, because that argument is then passed as the parameter. Now, if you remember, I said previously, prior to 16.8, React was written as a class definition. So that means working with state management was pretty similar to this example that we just discussed, right? So when we use ReactHook, we don't have to write this entire class. We don't have to create getters and setters, and then we don't have to use that getters and setters in our actual program, right? We just have the ReactHook itself. So what happens is when we have to establish the initial set or the initial state of the object. So let's say I have this input text, right? And I want to store this input text in some sort of a variable. So I would write something along the lines of let top text equals to an empty string to begin with. I can do this, but this is not being tracked by state management. So if I need to set up an state management based declaration of the initial state of my variable, I will have to combine this declaration with this particular function. Okay, and I will have to pass in the initial state to it. So instead of writing this, I would have to change this. Okay, and I will have to make a call to react.useState, and then within that, I need to pass in the variable which I'm going to track using state management, right? All of the variables, okay? So it could be a single variable, it could be an entire object, which will have a bunch of key members, right? Whatever it is that you want to pass it, you can pass it, right? But you have to remember how many key values that you have passed. So here, I can probably have some sort of an object if you want to set up an object, right? So object are always with these curly braces, that's how declare an object. And then I can say here that my first key member is going to be top text, and that is going to be an empty string initially. And then my second key member is going to be my bottom text, and that is also going to be an empty string. So I can set this up, essentially, I can work with this. But notice here, this allows you, and we need a comma here to separate the key values, right? So, and then there will be a semicolon. But notice here that this is a method, and this method is going to return you something. Okay, what it does return you is basically, so here, what does a useState call return? Okay, so the answer to that is it returns basically an array of 2 index. Okay, the first index consists of the container which will store the value. Okay, so anytime you want to store the value, you will essentially have that particular container. So here, the container will be an object in this particular example that will consist of 2 key pairs, okay, 2 key value pair, or well, 1 pair or 2 values, one which is the top text of the mean, and second which is going to be the bottom text of the mean. The second index of the array is going to consist of a callback function, okay? And that callback function is essentially the setter. Okay, so that means anytime you want to update the value inside this container, whatever information that you have inside this container, if you want to update that value, you cannot use the assignment operator. You cannot use top text equals this. You cannot do that, right? You always have to use this setter, which has been returned by the useState when you are doing the initial state declaration. And then to that, you will pass the value just as you would here. Whatever your new value is, you will pass that value. Okay, so that essentially is how you work with your getters and selves, right? In React.js, you don't need a getter. Okay, you can think of the fact that this container is your getter essentially, but you don't need to call a getter separately. It returns you the container which has the actual variable, so you don't have to worry about it. So that means now if I want to complete the declaration of this particular guy, okay, I need to first provide what is going to be the name of the object that we'll have, right? So we will be using what is known as object destructuring, array destructuring, not object destructuring, to bring out those indexes into its own individual locations so that I don't have to call this array all the time if I want to get my container's value, or if I want to call my setter, I don't have to do array 0 or array 1 in order to access this. Right? I hope everybody understands what I'm trying to say. So the syntax that I will use is basically to destructure the array and individually extract those two indexes. So every time I want to kind of refer to them, I don't have to use the array notation to get to that point, right? So what I can do here is something like this. I can give the scope specifier to destructure an array. In contrast to an object, we don't use the third brackets or the curly brackets, we use the third brackets, right? Within this, we are going to write the container name. So here I can say meme text. So I can do something like meme text, okay, because it is top text and bottom text, which is represented as an object. So this object label will be meme text. And then I need to give a name to my setter for this. So remember, setters always have the prefix set first. Getters always have the prefix get first. That is coming from OOP, object-oriented programming. So I'm going to say set, and then I'm simply going to provide the name of my container here. So that is going to be meme text itself. Make sense? And this will be then assigned to this call. So that means when this call is executed, when this method call gets executed, then this is going to return a container where the values will be stored. The updated values will always be stored. And anytime you want to read the updated values or the most recent values, you're going to refer to that container. That container is this first index of the array, which is in its destructured format. So I don't have to use the array notation from this point onwards. Anytime I need to refer to the container, I can simply do meme text dot top text, and that will give me the most recent value. But anytime I want to update the text, okay, from wherever within this particular functional component, I have to get this set meme text. And remember, this will have two different values. Okay. For beginners, if you have difficulties working with object storage, then what you can do is you can separate it into its individual values. You can separate it as a variable instead of an object. So you will remove the curly braces, just keep one value here, and then this will return a single value, and you will update a single value, just like we discussed here in this particular example. Right, working with single value. So this is basically the idea of useState. Okay, so this is what it is doing. So if we use this particular method call, we don't have to write our own class altogether. We don't have to define everything. So the ReactHook makes it a little bit easier with respect to working with this particular element here. Right, so that is what you have to keep in mind. Okay, so the next question is, how do we set up? So this is the state management itself. So the next part is to how to connect this to the event. So right now here we have an event, right? So we have to establish the event listener, and all we have to do is whatever text this event listener grabs, we need to use this set text. Where is our set text? Here, the set text, and we need to basically call this setter, and that will update the text that the user provided. So the next challenge that we have essentially is to conceptually understand how to implement our event listeners. So before we begin, question to you all, do you understand how the state management works?
Yes.
Everyone? Because if you do not understand this going forward, nothing will make sense, especially in the React Native, where we are going to do that Uber stuff. So if there is any question, you can ask me now, you can ask me later, but you need to ask yourself, do you understand how this structure works, right? Where it comes from, what is the motivation, how you need to set it up for any scenario, not just for this, but any scenario. You need to, in your head, you should be able to generalize how this thing works and then be able to code that when you implement it, okay? So please revise this. Without this, you cannot move forward with interactive apps in React, okay? All right. So the second thing that we have to learn conceptually is how to work with event listeners in React. Okay, this is simple to a certain degree. There's always a catch, but it is straightforward to a certain degree with respect to how you are going to work with it, right? So essentially, when you do some sort of event listener, you have to specify two things, right? When you're working with event listeners, you need two things. One is what event. Second is what to do when the event happens, right? This is the only two things you will need for event listeners all the time, no matter what technology you're using and stuff like that. It doesn't matter. The syntax has changed, the structuring changes, but the core concept always remains the same. What is it that you're tracking? What will you do if it does happen, right? So as we discussed before, in React.js, when you are going to implement event listeners, then we have to implement it using, or we will implement it using HTML-like attributes, right? Because JSX makes that process a little bit more simpler, right? But a good read is to actually read, and I will leave this reading to you guys, is what is the difference between the JavaScript method of doing event listeners, which is add event listener, versus the HTML attribute on click or on submit or whatever is on change, whatever happens, event listener. So we need to first refer to this area where we can say event listener list in React.js, right? So we need to search for this. Right? I don't know what website is this, but let's see if this has what we are looking for. I just want the list of event listeners, man. Where is my React.js documentation? What I'm trying to show you is basically the different types of event listener that we have in React.js itself, right? So that is what I wanted to show you. And how easy it is. But if somebody can find it before me, I would appreciate that if you can share it. But I think I have it here. So I'm just going to show it through the documentation itself. Okay. So what I'm essentially looking for is the different types of what do you call it? The types of event itself, but that is what they don't list here. So that is kind of like a little bit of a sadness, I guess. But anyways, there are 3 or 4 different types of main event listeners. There are more than that, obviously. The first one is if you are creating an HTML form, which is what we can also create for ourselves if you would like to. That is, we can wrap all the input fields, the buttons, the radio buttons, the checkboxes, and we can wrap it inside a form. If you have a form, then essentially what we want to keep a track of is when it is submitted, if it is a form, right? If you're working outside of a form environment, essentially, then there are things like on click. That is, if you're tracking specifically a click. You have on change. That is, if there is some change to the field that you're working with. Okay, so that is there. There are certain things like on key press and stuff like that. So all of these different ways you can essentially code it. But how you do it is that you provide it as an attribute to the element that you're trying to code, and then you specify what you're trying to track. So here, what is this? This is a input field, right? So that means if I want to code it in JSX, I would write something like input, okay? And the input we know is a self-closing tag, so we will close it here. And this is JSX syntax, keep that in mind, okay? You can give it some sort of a class name. If you would like to, just as we did for the other stuff, we can give some sort of a class name, let's say XYZ, we give it this. But now you want to put an event listener. What event listener do we need to put? We can have a key press, yes, but a simpler way of doing this is that anytime the content of this particular field changes, you keep a track of what change is taking place. So essentially, the event listener that is kind of appropriate for these kind of text field situation where there is no click. If you create this button, when we code this button, we need the on click, right? But if you're not doing this, so essentially what we need to do is we need to track on change. We need to track this particular attribute, okay? And when you do this, so two things, what event? Event is on change. Now all we have to do is what should you do when this event happens? So that means it is some sort of a function logic that we have to implement. Now you can write that entire function here itself, right? You have the option to inline it. That is, you write the definition wherever the call is being made to the function itself, right? But this will make your code very messy because you just want some simple HTML like field here. So you don't want to kind of write the whole function definition of what to do when a change happens here itself, right? So what you do is basically we do a JavaScript call to a function, okay? And then we can write a function call something like this, handle on change event. Okay, so we can do a function call. We don't need the first brackets. Please keep in mind when you're doing the function call in this particular situation, you don't need to write it down. And what you can do somewhere before this particular code begins, right? You can create what needs to be done when the change takes place. Okay, so that means I can do something like this, that is before this particular JSX syntax comes, that is before my return statement of my functional component, I can write basically the logic or the body of this particular function. So I need to define this as a function. So I would write function handle. Can I just copy this all together? Okay, this is a function. And remember, just as we worked in JavaScript, any function that is a logic to our event listener will take an input parameter, which is the event parameter. Okay, and I always use E to signify that. We have done this in the calculator app. We have done this in the quiz app. So I'm not going to go too much into it. So you pass that as a parameter to this particular function, create the body of the function. And what you do here is basically you can strip all of the different values that could be present here. Okay, so that means if you do e.target, all right, this target is basically tied to this particular input field, which is being tracked. So any values that is coming from there can essentially be stored in that particular target, right? So this requires you to track the name of the element that you are working with. Okay, so that means here, I need to give a name here. So I would say name equals top text. And then I can have multiple input fields with different names. So I can redo this and I can do copy this, let's say, and I can come here, I can paste this, and I can do here, I can give the same class name because it belongs to the same input category. On change, I can review it at handle on change event, but I need to change this name to bottom text. Okay, so now we know for a fact that this event listener function will be executed whenever both of these situations notice that there is a change in this particular field or the field that is right besides this particular field. We know for a fact that it's going to execute that function, right? So when it comes here, what we can do is that e.target will capture both of those different function names itself, right? The names that is calling those particular function. So we can essentially store those individual names into those particular fields, right? If we want to, right? But we need to remember that these names that we provide here must match to the names that we provide here, because we need to essentially connect the different variables to a useState call at this point of time. Okay, and the useState call is basically going to be very important, right? Because it is going to help us understand that if we have a same function call, you can of course choose to write different function call that will relieve you from the complexities of what I'm trying to explain to you now. That is, if you're tracking the same event, then it is just better to track track it through a singular function and then separate it based on a different label or a different identifier, and then work it differently, right? So here, this is an object. I know that. So I can do some sort of an object destructuring, and I can bring in the different things such as top text or bottom text. Okay, and I can add that to my stuff, right? And then what I can do is I can return. So I need to close this function at this point of time, right? So I need to end this, but I need to end this by updating my state, because this brings me the value of this particular object, right? So this value has to come, and we need to also provide a value here, because that value will be grabbed from the user essentially. So you have to keep in mind that those values is what will be provided. So you have to do something along the lines of value dot, and then whatever value is being provided. So remember, this will have some sort of value, and that value is going to come from the user itself, right? So if this is kind of labeled inside the form, something along the form itself, then you will have something as a form data dot, and then you will have bottom text here, and then you will have form data dot top text here, the same thing in a simple fashion, right? And I'm not doing anything new here. Please keep in mind that everything that I'm doing, this is just your knowledge from HTML. So if you revisit your HTML stuff, what are the different attributes is necessary to set up an input text field? That's all I'm doing here. Okay, and this is basically wrapped inside a form environment. So I'm putting a form environment. I should write it that way. So this is basically wrapped inside a form environment that is wrapping all these input fields. So this takes care of the fact, right? So these are the different things, and these are the values that you will receive from the particular field, and then work with that. Okay, so once you receive that, the last thing that you have to do, and let us quickly just wrap around the concept, and we will go over it a little bit slowly the next time. Again, I just noticed that we crossed the time. So essentially, you will have to call your setter. So your setter is this guy here, state. Where's my state? The set meme text. So we need to call the set meme text. Okay, in that, it will be a callback function which will take the previous data. So we always write previous form data if it is wrapped in a form, or if it is single value, then we will say previous value of that variable. And that will be passed into a callback function. And that callback function is essentially where we will reassign this particular situation, right? So we will return the previous data here. Okay, so we will first of all, with these 3 dots, this is a syntax. It is to basically store the previous data, okay, and not to overwrite it. So we are keeping this, and then we can assign the meme text dot top text equals to the new value that has been provided here, which is wrapped in this event variable, and then do the same thing for the other one as well, side by side, right? So that is how we are going to set this up. Okay, so we will stop here. We have overshot our time by quite a bit. And then we will essentially continue in the next class how to implement all of this formally, this logic into our actual code. So please revise what we discussed today, because it will be important for you to follow along with me as to what we are doing. So if you do not revise, it's going to be difficult. Okay, so I will see you all again next Thursday, where we will start implementing this pseudo codes that we discussed into actual code format.